Hey guys, my name is Sagar Batani, and I am a student in Professor Fenton's 2211 physics class, section M05. The public lecture I attended was conducted by Tom Murphy on November 11, 2013. The topic of the lecture was estimating our energy predicament. A main point of the lecture was to first introduce Fermi problems, which are basically unsolvable problems in which assumptions are made to attain an answer, as well as to show the purpose of dimensional analysis. Another main point in this lecture revolved around targeting climate change. Murphy did this by analyzing both carbon dioxide rises and temperature rises. A third main point of this lecture was whether or not a replacement to fossil fuels exists. This was done by analyzing abundances of other known sources of energy, as well as constructing an alternative energy matrix to represent specific considerations. The last two main points Murphy discussed were ways to store energy and the fuel economy of cars. He discussed the former by analyzing ways various forms of energy are contained, and analyzed the latter by explaining electric vehicle math. I found this topic interesting because I have always heard people speaking about the fact that we are in an energy crisis, and that global warming is a near and significant problem, but never really found any reliable analysis or data that led to these conclusions. So when Murphy addressed these problems from a physics standpoint, I was intrigued to say the least. Something I learned in this lecture was how to even use Fermi problems. I was always aware that sometimes assumptions had to be made, however, never knew that a mathematical application was used to solve some of the world's unsolvable problems. In order to demonstrate what I learned, I will do an example of a basic Fermi problem.
So the question we're trying to answer today is how many piano tuners are there in Los Angeles? Now this problem seems pretty far-fetched at first, however with the Fermi problem methodology we should be able to solve it. But first we have to make some assumptions. There are 4 million people in Los Angeles. There are 2 people in every household. 1 out of every 25 households has a regularly tuned piano. Pianos are tuned about once a year. It takes approximately 3 hours to tune a piano, with travel time included, of course. Piano tuners work 7 hours a day, 4 days a week, and 45 weeks a year. So now we can move on to the dimensional analysis section of this problem. So we have to take these 4 million people, and we multiply that by 1 household over 2 people, and then we multiply that by 1 piano per 40 households. And then we multiply that by 1 because it's 1 piano tuning in a year per piano. So this dimensional analysis essentially makes it so that we can cross out variables to get to the final variable that we want, which is piano tunings per year in Los Angeles. And so the number we get would be 50,000 piano tunings per year in Los Angeles. Now we want to solve for the amount of piano tunings per year per piano tuner in Los Angeles. So we know that this piano tuner will work 45 weeks per year, and then work 4 days per week. And per day they work 7 hours. They work 7 hours per day. And it takes about 3 hours to complete a piano tuning. So that means that there will be 420 piano tunings per year per piano tuner. So what we want is that how many piano tuners are there in Los Angeles? So to cross out and solve the variable, we take the number we attained first, 50,000, and divide it by 420, and then we result with 119 piano tuners in Los Angeles. The key to this problem is crossing out variables, as you can see through dimensional analysis and the final division that occurs. And keep in mind that 420 piano tunings actually represents 420 piano tunings per year per piano tuner.
Another thing I learned from this lecture was that types of energy such as ocean thermal energy and fusion are not only readily available for the future, but are also considered abundant, making them very appealing to use. A concept of this lecture I followed up with was to further analyze the energy crisis in a country that was not the US. The country I chose to analyze was Pakistan. I learned that a major issue of not being able to globally convert to greener sources of energy resides in a lack of strategy and political will. It's easy to assume that most countries would be on board with other forms of energy. However, the key issue for countries like Pakistan is the monetary and political responsibilities that come along with this energy reform. I thought that it was extremely interesting that the energy crisis can be attacked from a multiplicity of varying perspectives. All in all, I found this lecture to be an extremely unique and interesting way to address and actually estimate the energy predicament. Once again, my name is Sagar Batani. Thanks for watching, guys.